Good morning, everyone. My name is Prince Aminu. A graduating master's student from the University of Delaware. This morning, I'll be talking on an investigation into the fracturing of asphalt pavement surfaces using Daikon Radishes. So, as we all know, the United States, as we've been seeing in the conference over time, is one of the top 3 nations in the world with the use of impermeable surfaces. And then worst part is some of these surfaces are no longer in active use. They have been left abandoned, and then nothing is being done on those surfaces. And actually, because of the past, some are left for decades of years, and then reducing the quality of the pavement itself. Therefore, some of these pavement are no longer used. So therefore, we engineers sometimes don't spend as much time in getting machines that can remove such pavement because they can't be used even currently. So therefore, this pavement has no incentives, either financial or economical value. But lying abandoned doesn't mean the pavement are not environmentally negative. They can be lying there, but yet they reduce infiltration rate, causes urban heat, and several other environmental hazards. So the conventional approach of removing such pavement is the use of the milling machines, which I've said has no financial incentives, so it's not mostly used for abandoned pavement. And some pavement are also lying in, say, cemeteries where this equipment cannot get into. So we check a new idea using the plant radishes to remove such pavements. This idea started in 2019 by Feinberg, where he was thinking of how can we remove pavement without using industrial equipment. We don't want to contribute more to environmental pollutions by burning fossil fuels to remove such pavements. The idea of tillage radish came from agriculture, where radishes has been used to alleviate soil and then in the world no-till conditions. So we're trying to say, okay, this radishes has been used over time in agriculture. Can we bring it to transportation and increase transportation sustainability? So to evaluate, we try to evaluate the structural impact of using this radish at a particular test site down at Winter, Delaware. The radish has been grown since the spring of 2021, and then it is grown biannually, and we try to check what is the impact of the radishes over this growing period, over this planting seasons. So what we intended to find out is, as cracks improve in this pavement over the planting of this due to the planting of these radishes, as the water infiltration rate of the pavement be improved, can we remove some of this pavement by hand? So to do this, at the end of every planting seasons, we took pictures of the site, about 20 pictures each, and we tried to map out all the cracks that we see, and we measure those pictures together using AutoCAD, and we have those results. So I don't know if you can see closely, the shaded white is the pavement that has been removed by hand. We discovered that this pavement no longer need mechanized equipment. We can simply go to the site and then remove such pavement by hand. The white is the cracks that were made on the pavement. And we noticed a new, actually to say, each of the radishes that was planted on this pavement was drilled with holes. And as you can see, it seems like in a definite pattern. So we're trying to remove the attribute of neglect from this pavement. So we try to when we plant those radishes in those holes, as they expand, we notice that the cracks begin to connect across the holes where these radishes were planted, and we separated such cracks. And over the time, we also observed that the radishes was able to grow beyond the size given to it as it expanded its size. And we have some results showing that the cracks have been increasing over the planting seasons. And we have about 34% increase in crack over about 8 planting seasons. And then 74% of these are along the radish planting holes. We also discovered that 5.2% has been exposed by hand and about 4.3% by the paved. We also tried to measure the water infiltration rates, and we discovered that it has improved compared to pre-planting period. Actually, it will interest us to know that mere drilling of holes in this pavement did not improve the water infiltration rate, because we did measure that at those locations, and we discovered that it is until the radish begin to grow and expand that we can improve water infiltration rates. We also try to like check the radish in our own little laboratory, and then I tried to like develop a prototype where it was bounded by spring to actually check the capacity and the ability of this plant. And then we observe the plant at its a great tenacity to like go against constraints. We measure the ability of the plant, and we discover it's able to grow beyond 12 psi of constraint. And this value is very important in pavement engineering, because when pavement is subjected to such stress for a long period of time, it can cause the pavement to undergo severe cracking. We also did measure the life cycle assessment of the radish to check if it's environmentally friendly, and we discovered that its emission is about 9.73 to 9.99 kilograms of carbon dioxide for a year. And we discovered this emission is similar to 1 gallon, burning 1 gallon of fossil fuel, which was quite low compared to us. So in conclusion, we discovered that this radish is significant in increasing crack in pavement, and it can also increase water infiltration rates, and then root can grow under confinement, and it has low environmental impact. This promising pilot results indicate the need for more research via funding and sponsorship in this field. Thank you for listening.
Any questions? Is there concern about the asphalt being left being toxic, the toxicity or quality?
Yeah, there's okay. She wants to know if there's concern regarding the toxicity of asphalt being left. Yeah, so currently what we do now is at the end of the depaving, we remove such asphalt pavements and we try to like store them. If it's needed for recycling, we can like send it down to the wherever it is needed to be recycled. But we clearly know that these pavements are kind of like low quality, and asphalt pavement has a way of disposing such pavements.
Can you tell me this measurement all aspects or different kind of asphalt? Because the picture you showed earlier showed the white asphalt, but if you're doing the black one or porous one, and these different kinds, and that also.
Okay, yeah, you want to know if this method works for all kind of asphalt, and then the picture I showed shows some white asphalt. Yeah, actually the picture that I show is the normal porous asphalt that we know. The white shading is the location where we no longer have asphalt, because the radish has been able to like help us remove such asphalt by hand. And we also discovered that currently on this paved site, we can actually remove all asphalt using shovels. So this work for this particular asphalt, as I said, more research needs to be done on other asphalt, on how we can expand this research work. But currently, asphalt materials behave the same. If this particular asphalt, we did test the asphalt materials and we know the strength and its property. So picking this radish to a similar asphalt material, we expect similar results. But when the strength improves, then that is where we need to do more research and actually see how long it will take on this situation. But one thing of interest which I would like to say is that the radish has a unique nature of going deep into the pavement, and by going deep into the underlying subgrade, where it can weaken the subgrade of the soil under. If you can weaken the subgrade of an asphalt pavement, you can destroy the asphalt, no matter the kind of asphalt, no matter its strength, no matter its property, anytime, any day.